Hi, everybody. My name is Serhi. I'm CEO of Talsec. This company is mainly known for its app protection SDK or app shielding SDK, which is available for free. It's called freeRASP. It's available on GitHub or PubDev. So today we will show you some most exploitable threat vectors or attack vectors. We will show you some remedies or some solutions that you can use to prevent these problems, to solve them using free tools or make something in-house or use some commercial tools. The practical part of this session will be presented by my colleague Tomas Soukal, who is mobile security expert in Talsec. So what you will learn today is mainly the threat vectors and some solutions. While talking about threat vectors, of course, it's impossible to have a full possible threat vector analysis of the threat modeling workshop and all the aspects of threat modeling. So we only give you some appetizer how this kind of exercise can be done. And we will focus on the threat vectors which you see currently on the screen. So the first type of problem will be related to app cloning, app repackaging, and app tampering. So this is a possibility how malicious actor could make copy of your app and do some changes inside it, how it can be repackaged and probably even upload to the app stores or to distribute it any other possible way, which are quite many available today, especially if you talk about Android. We will talk more, and Tomas will explain you more about hooking frameworks and potential risks linked to dynamic attacks, how the app can be compromised using these techniques, which is quite popular and well known. There are a number of tools available, such as Frida, IDA Pro, and others that can be used by pen testers, and this, of course, it can be used by malicious actors such as attackers and hackers. And another group of problems or attack vectors which are based on reverse engineering. So here we will focus mainly on two potential problems, which is quite gaining popularity and becoming really tricky to mitigate and make something against it. And we will show some tricks and hints how we can address these problems. These are related to token hijacking and app impersonation or user impersonation, how the attacker can misuse API, gaining the credentials and getting the necessary information about API architecture from the mobile app using reverse engineering techniques. So that's mainly it. And of course, we will, before we start looking at these problems, there will be some time dedicated to general mobile security questions. So that's basically it for me. Not to spend a lot of your time. Please welcome Tomas, and let's the show begin. Thank you.
My name is Tomas Soukal, and I'm a mobile security doer, speaker, reverse engineer, and mobile developer who works for Talsec. At Talsec, we do mobile application shielding and backend protection. So we have a lot of know-how that we would be very glad to share with you today. So, like first key thing that developers need to be aware of is TOFU, and I don't mean the food. I mean trust on first use, because once your application lands on a final device, on some user's device, you have virtually no guarantee that the device is safe to operate, that the user is a good user, not some evil actor, and that your application is still your application. So maybe there are signs of malicious activities, Maybe your application client was somehow tempered and now serves as Trojan horse for someone else. And maybe you need to warn user that something bad happened or something doesn't match up. So can you communicate securely with the client application? Can you trust? Is this some? Do you have any checks to ensure that your final application is safe? And finally, can you store sensitive information on the client because maybe the application doesn't have sufficiently sound storage, because a lot of mobile devices have like software and hardware based storage for example keys, and it makes a tremendous difference in a security of this storage. So always like check on first use if the device and application are safe for operation. A lot of time I need to answer quite a difficult question, and that is that whether, as you probably know, Android and iOS operating systems provide really a secure application sandbox. So what's a secure application sandbox? It's like a concept that should make an application sandbox, like impenetrable from other sites, and it should be like immune to stealing of data from some third-party app, or that like it should be self-sufficient in its own box. And this simply is not true, because there are various technologies, methods, and approaches that break this concept. So, for example, I have 6 examples there. For example, if you have a rooted device or already infected with some malware from factory, you can't rely on this sandbox. Of course, US developers already know emulators, and those allow you quite a lot of like various tricks and various you have like a lot of privileges, so you can inspect applications data, for example, and emulators already come rooted. That means that you can do virtually anything with applications data, inspect everything. Third is third-party dependencies, because maybe you didn't check that the great plugin you added recently is really safe, and maybe the plugins you added to your application are serving for malicious purposes, and maybe they will just evolve into malware later, as it's quite common nowadays that initially safe library plugin or anything will become, it's called weaponized in some future. Also, as we know, operating systems deprecate and are updated and upgraded to better versions over the time. So there are still evolving new exploits on other vulnerabilities in unpatched OSs. You can check, for example, Android website where there is a monthly bulletin with all security patches that were added, and I can tell you that there are quite a lot of them. So you ideally should run in a patched OS with the latest security patches. But the reality is that a lot of device vendors don't update devices beyond, I would say, like 1 or 2 years after the device was released. So you have definitely millions of users that are running some old devices with unpatched OSs, and various exploits may be used from some malware to penetrate your application. Also, less common but still relevant are hardware exploits. That means like chipset like MediaTek, Broadcom, Qualcomm, or other companies also need to keep their microchips updated. A lot of times there are attacks through Bluetooth stacks, so devices that have enabled Bluetooth can be penetrated virtually over the air. And finally, like the sixth thing that may breach a sandboxing concept is repackaging. So that means someone takes your application, creates a fake clone, injects some backdoor malicious, and I will show it later. So as a hacker or as a reverse engineer, I need to know what tools are available and what can they be used for. For example, to gain a root or escalated privilege or jailbreak on iPhones, I have available various technologies like Magisk, dopamine, or kernel SU that may like help me to get this escalated privilege to do whatever I need on a device. If I need to like instrument application and check its inner like workings and how it like it's quite similar to debugging, I will use a Frida. Frida is a hooking framework or instrumentation framework that allows me to check, for example, cryptographic operation, file system operations. I can also monitor various system APIs that are used. So, for example, whenever your application receives a JOT token and then uses it, I can monitor the usage of this JOT token. A really great tool for Android reverse engineer is APK tool. APK tool serves as like a build and rebuild tool for applications and is usually used whenever I need to create a fake clone of application. So I just download your application from Google Play Store or from some mirror of Google Play Store, and then I can simply like rebuild the application, inject whatever I need. So APK tool is like a standard tool in this area. Whenever I need to like quickly assess statical security or like statical posture of security of your application, I can use mobile security framework. That's a like drag and drop tool that allows me to quickly check anything that can be statically found from your application, including various, for example, included secrets in your code, IP addresses, or web endpoints, uh, included emails. So whatever you include can be visible, or whatever you add to your code is, of course, readable to attacker as well. Then there are tools like Lucky Patcher or similar, maybe like U2Vents and other technologies that provide like cheating capabilities readily on device. So, for example, you can modify application on with a few clicks from their device with the Lucky Patcher. And if I really need to like deep dive into native code, maybe you included some like native library that does some cryptographic operations or tokenization or other stuff. I can use Guidra or IDAPRO or JEP for like decompilation or disassembly of your code to see what was originally written in like almost original way. And there are the tools, so I won't bore you with those. I will start with a first threat modeling example, and that's app cloning. App cloning leads or like related terms are repackaging or pirate copies or like it's used, it's spread thanks to social engineering. So this involves like uh, creating a fake clone of your application with the aforementioned APK tool, and this may lead to data breaches, leakage of your PII or financial loss, and definitely damage to the original app's reputation. You probably heard about clones yourself. Like there are dozens of sites that promote various, for example, game clones with, for example, disabled rate limiting or removed ads or like some cheats for first player shooters, so some aiming modes for players. Uh, I have a great story about this. Uh, about application my friend made. It was called Better Vision, and this application uh, had its in-app purchases stolen, like literally. This application suffered a cloning attack, and as I said, in-app purchases got stolen. So this attacker took whatever new version was released and create a clone instantly, and these clones actually weren't like for free, but attacker replaced the payments code like with attacker's own payment gates. So these fake clones were still paid, but payments were to someone else. So this repackaging is simple. You just take the application, use APK tool or similar tools to, I would say, like open this box of application, and then you inject, for example, your own payments gate or other stuff, and then box it again and ship it to victims. Of course, after this repackaging, the signature of application is broken, so it can be detected by some tampering tool, and that's something I will show you. So, but before I will show you this repackaging attack, I have some like ideas what attackers can do and what they just do. So they can inject, for example, some code into your main activity, or they can add custom smiley code, like they may use some pre-built libraries they inject automatically to every application they repackage. They may also open some browser intent to some malicious websites, so your victim user will open your application, but the application will immediately open a browser with attackers controlled website. And as I said, there may be added custom activities, paywalls, advertisement, or it may be used for credential harvesting. That's something that is used to like collect credentials from all the users, like in a big bunches. And also this may be oftentimes used to load native libraries with reusable malicious code. Okay, and now I'm going to turn the second threat model, and that's hooking. This attack vector is used to like get insights into API's architecture of application, like backend architecture, and to manipulate the code during the runtime. So application can like it's really similar to debugging. So I can visit all parts of application and see what values are passed between different functions and places of between different places of application. And it can also be used for network traffic sniffing. So I will show you also an example where I sniffed traffic of application, and so it's a really powerful attack vector you should know about. There are tools like Frida, I mentioned, but there are others like Medusa or RMS hooking framework, and they already come with pre-made scripts That's something I forgot to tell you. With hooking, you write usually like short JavaScript scripts there where you instrument the application. And these scripts are already pre-made oftentimes. So for common operation like SSL pinning bypass or UI restriction bypasses or classes enumerations, you can just drag and drop a script from these tools and be ready to go. So it's quite simple. You don't have to like develop anything, and you can start quite quickly with hooking. And that this hooking may be used for monitoring of encryption keys or intense HTTP communications, file operations, of course, databases, Bluetooth operations, literally everything your application can do, hooking can observe and monitor. And this is a time to like show off like a great solution to many mobile threats, and it is a freeRASP. FreeRASP was developed in Talsec and is like a one-stop shop for all basic uh, threats. So whenever you need to check from within your application whether the device is rooted or jailbroken, or to monitor reverse engineering attempts and detect those hooking frameworks and other stuff. And also if you need to ensure that application wasn't repackaged or that it wasn't, for example, installed through some shady third-party app store or distributed through some Google Drive, whatever, you may check this library. Today we have a really lively community there, so you will get a lot of help with your application, with your security. So it's really another great benefit of this freeRASP community. And also, I have to like, uh, I'm really proud about it, that freeRASP nowadays protects almost 4,000 of applications. I mean, like distinct package names, it's billions of instances. So this is like a one-stop shop for a lot of mobile threats. That's like not the uh, on the level of like banking industry, but for a general usage in many applications, you may test it and see for yourself if it will help you. Okay, and speaking of reverse engineering, for example, you may imagine the use case when you want to, for example, inspect some website and you need to get API key. So you can check the application with the tools like Mobile Security Framework or manually just use in your command like some command like strings and the application to enumerate all strings in application and find the relevant API keys. And this reverse engineering, I have it like separate threat modeling because it's like more complex than those previous attack vectors. And this may lead to leakage of sensitive data or application logic or like your valuable, for example, machine learning models and your API keys. And for example, you need to reverse engineer application whenever you need to capture transmitted data properly. I recently reverse engineered some gaming application that had a lot of interesting data stored directly in shared preferences. Android developers already know shared preferences as the default storage for simple data. And for iOS developers, there is some, I don't recall the name, but there is also similar basic file used for some preferences. And this gaming application had a lot of information stored like ID and name of the player, JOT token used to authorize this player's session, and all the game configuration data like free games, advertisements, and some timeouts and things like that. So by modification of these shared preferences, I could like get unlimited game time and unlimited games and other stuff. So this is something that reverse engineers go after, because then they can easily share this game with the audience and maybe inject their own payment gates or advertising, as I showed before. Similarly, we did recently some exercise with an application where we extracted its JOT token and then tried it against the backend. So I will show you how we did it. So now I'm moving to the part where I'll be discussing more the API side of your mobile application. I mean, like backend that you already use. But for example, on your backend side, you have some API protected by, for example, API key. But as I already displayed, it's quite simple to get hands on your API key. So how to protect your API against threats remains the question. So your API usually consumes like data from your applications, but also it allows us to download valuable data from your databases. And from your application side, as a reverse engineer, I will probably go after your API architecture or source URLs or HTTP headers, and I will definitely check transmitted data like the JSON files you sent from application or received from your backend side. So this is like a viewpoint of reverse engineer. And we recently tried MyBMV application. That's the application used to control your car, where you can honk the horn, open trunk, turn on some ventilators or heating, check some charging status and other stuff. And once we did all this reverse engineering stuff, we could monitor in a burp suite every jot or every request coming from to application. So as you can see, I could simply see that what's my application ID, what are some preferences of application and other stuff. We discovered that this application was using Google Firebase. You probably know Firebase. That's storage API, cloud storage, and it's also used for authentication, Firebase authentication. So this application was using Firebase authentication, and I wanted to grab the JOT token to be able to sign in. So it's also possible. It's like no magic. So I just visited shared preferences in the application, and there was a file with this cryptic name that essentially hold my API key, my JOT token. So it's somewhere in the middle. I just copy pasted it into Notepad. So this highlighted area is a JOT token hashed to base 64. So when I pass it to JOT.io encoder or decoder and zoom in this violet section, I can see that this is my email. Here is a sign-in provider, that's password, and my user ID and other stuff. So this is JOT token. For those who haven't seen like content of JOT token, that's like a standard technology for sign-ins today for authorization and authentication. And like a full chain of such an attack could look like this. Imagine some attacker creates a fake clone of your application. That's the first step. Then spreads it amongst your users, and then to collect or like harvest all their tokens once they sign in. And then the attacker may be able to make malicious requests against your backend, impersonating real users to profit. So this can be done in like a great mass and cost to a lot of profits or your resources based on your line of business. So what are common app and API threats? API abuser, like someone attacks your API to, for example, scrape your data. It's really common in the e-shop or e-commerce world, where competing uh, players are scraping the prices of competitors. Also, scalping is interesting. It's whenever someone tries to use your marketing or promotional or benefit campaigns to collect all those, like for example, you offer some free items or whatever, and someone may be able to extract all those free or promo stuff for himself. Uh, and then your API may be threatened by some botnet that may be simply bought by someone to make your business malfunction. Like there are already services that offer to order a botnet for $3. Then you also have fake registrations that's connected to abusers who would like to collect, for example, some sign-up bonuses that you offer. And the really dangerous one is impersonation. That's, for example, when someone creates a fake clone of your application and uses this impersonated application to act as someone else on his or her behalf. Uh, Then there are, of course, brute force attacks that are quite known, that someone may just try millions of requests against your backend to extract some data or to maybe breach your security uh, measures. And really interesting is also session hijacking. That's when someone tries to impersonate someone, but by getting hands on the session. And of course, DDoS attacks, when someone creates a denial of service on your backend. So the ultimate question is how to block traffic coming from unauthorized clients other than your application. So nowadays we have some technologies for that. I will mention those later. But before that, I'll introduce another threat model, and that's malware. Uh, Malware in terms of like mobile apps, maybe for example SMS stealer. That's some application that reads SMS that may be used, for example, to capture second factor authentication messages with some pins or other passwords. Then we have Keyloggers. That's a kind of malware that steals users' inputs. So like there are malicious keyboards, because you can install keyboard as an application on Android or iOS, and it may be used by someone to grab everything user types in. And then we have Tapjacking. That's kind of attack when someone like an attacker or like this malware displays a transparent overlay application that's virtually invisible on top of your application. So imagine like a sandwich of application, and this top application is again doing something like keylogging, like stealing all users' taps on the screen. Oftentimes, accessibility services are misused because they are really simple to misuse because these are used to control device. So if an attacker is able to get this accessibility services capability, then the attacker is capable of doing virtually anything a regular user can do. Then we have also remote control malware. Those are malwares that may instrument device to serve as part of botnets or to like instrument, for example, SMS or phones or answering phones or other stuff. Uh, there are a lot of examples of remote control, like it's called RET tooling. A lot of those are even like open source, so anyone can build own remote control malware. And as I already talked about, there are various game cheats or other cheats that modify the legitimate apps. So this is like a malware that's relevant on Android and iOS. And of course, there you might have some third-party dependencies and other like really nasty malware that's already pre-installed by vendor or manufacturer of your device. For example, if those are some less known devices or vendors that install some unwanted apps or some advertising apps. So this may be also another vector how to introduce malware into device. Oh, I already discussed Tapjacking, so there you can see some image how it may look like. Of course, Tapjacking wouldn't be highlighted in red, but so to get some idea, this Tapjacking will create a virtual grid for each area, and whenever user taps that area, it's locked to attacker's backend. So it may be used for data stealing, as I said. There is example of ScreenLogger, that's application or that's malware I created that can read all the screen content by misusing accessibility services. So on the left side, there is some legitimate application, and whenever I type in information like my phone, my password, this application, my screen logger running in the background, was able to capture all textual content of the screen. So create account is here, this phone number is here, this password is here. So everything was captured easily. Here is some example of the stealer or like this remote control malware. I took one that was recently discussed in freeRASP, I think. So it's called reFlutter. You can check this link. It really exists. It's capable to request admin permission, and it runs in background and supports, I think it's nowadays supports all Androids up to the 14 version, and has some options like remote device screen lock, wallpaper changing, data encryption, delete of logs and other things. It can also steal notifications and collect those on attackers' Discord. So a lot of options. So, like some overview, because we are needing to the end. Uh, I have like some generic table that matches attacks, risks, and relevant solutions. So for routing attack, where the risk is stealing of your application's data, you may use some root detection library. Uh, for example, there are like multiple options, uh, but I will of course recommend our ones because that's the one I worked on, and I think that is like a leading library in root detection. So definitely check that one. For complex reverse engineering, where everything can happen, you will need a full-fledged RASP solution. There are various vendors of runtime application self-protection, that's the acronym for, of these tools. So these tools come with even more options for mobile security control and can detect various other threats like VPN presence or developer options and other stuff. So uh, I will call it like RASP, but you can facilitate it free RASP already in some ways. Uh, for attack like man in the middle, you may equip your application with certificate pinning to prevent data leakage via network layer. There are again like various solutions that are commercially or like already available in your mobile framework. The difference is usually that the default that are provided by Android or Cordova or Flutter or other mobile frameworks are static, and that creates a lot of issues during the life cycle of application. So it's better to look after dynamic ones. For hooking attacks that may result in runtime data leakage, you need to equip your application with hooking framework detection. For that, you may again utilize freeRASP or some other library. Uh, to prevent malware, you may need RASP with UI protection, and also there are available products that are capable of like scanning devices for installed applications or detect applications that were installed from some third-party store. So there are nowadays malware detectors available for that. And to prevent attack like jot stealing that may result in API abuse, you should look after technologies named like Epicrypt or device and app attestations. So this Epicrypt technology that's developed also by Talsec is really sound, like really great to prevent all those API abusal attacks I talked about. So definitely check this area whenever you need to prevent your API, mobile API against various attacks. Okay, and that's all I had prepared for today. So you can reach me also at Soukal at Talsec App or through LinkedIn. So thank you for coming today, and I hope you learned something new. And have a great day. Thank you again, and see you next time. Goodbye.